So, slight change to the programme. You might notice that myself, my colleague here are not Pete and Lisa. My name's Claire Ray. I'm going to be chair, and Pete doesn't need any introductions. Everybody knows Pete anyway. He's co-sharing today. So a little bit of housekeeping before we start. There are not any expected fire alarms. So if the fire alarm does go, you need to head straight to the fire exits, either side at the front. I'm not sure if there's any at the back. We've got a request. Please, can you make sure that you get your voting for the Best Exhibitor Award by 1320 hours on the conference app? You vote on the app itself. The annual dinner tonight, if you're booked onto the annual dinner, please can you make sure that you book your table through the conference app as well? And if you've got any problems doing that, please visit the table that's in the exhibition area. That's there's a desk specifically for the conference app, if you could approach them. And if you're not going to be able to attend the dinner, again, if you could just notify through the app, or if you could let somebody on the reception area know as well. And I think there is a waiting list of people that haven't got a place as yet, so that'd be very grateful if you could do that. And I'll hand you over to Peter now.
Morning, everyone. So just a couple of quick reminders as well. So for those of you that want to ask questions throughout the day, please just remember that within the Q&A section of the conference app, under the agenda, you can actually type in your questions. Similarly, obviously, at the end of all the talks, we'll have the usual discussion forum. Please put your hand up, wait for the mic to come to you, just so we can make sure that everyone can hear, both within the room and who is watching online. We have seen already that a question have come up around a box that keeps appearing online. For those of you that are online, we are asking the question about what we can do to fix that. If there are any further details, please just send in further details via the Q&A system, and we'll make sure it gets forwarded on. In terms of posters for this particular session, there are a couple of posters. There are 6 posters, which is good. So there's 6 posters related to these themes. So please do have a look at them, in particular in the poster area down in the exhibition area. So just to give you an idea of the 6 posters, the first is called Advanced Characterization of Micropore Networks in Nuclear Grade Graphites, Integrating SEM Analysis with Percolation-Derived Inverse Modeling. And that's by Bradley Moresby White. We've got The Carbon Cost of Radiation Protection, When Are We Doing More Harm Than Good by Christopher McKay. Decommissioning That Which Isn't Built Yet by Karen Smith. Eric PD, A Whole Hierarchy of Controls by Nigel Reeves. A New Variance Reduction Technique in the Monte Carlo Calculation Code Ray Expert, The Importance of Biasing by Leo Nowak. And The Defence Nuclear Enterprise, Community of Action on Radiation Protection Skills by Chris Jones. So you'll find them in the exhibition hall, and those are posters 6 through to 11. And with that, I'll hand back over to Claire.
So our first presentation is challenges of demonstrating the application of BAT for radioactivity monitoring at a nuclear new build. We've got 2 speakers. Introduce first one, Stefan Harbron. Stefan has over 9 years experience in the nuclear industry as a radiological protection professional. Stefan started his career in radiological and environmental team at Jacobs, and then moved to NMB Genco in September 20, where he focuses on compliance with the RSR environmental permits and provides advice to the company in areas related to radioactive waste and environmental protection in his role as corporate RWA. And Phil Kruse. Phil has over 25 years experience working in environmental radiological protection and has spent the last 15 years working in nuclear new build. Phil was responsible for securing the RSR environmental permit for Hinkley Point C, the first environmental permit for a nuclear power station in the UK in a generation. Gentlemen.
Morning all. So by show of hands then, who here can say that they're able to course through work without any hiccups or any mishaps? No, none of us. It doesn't matter which area of radiation protection we work in, which job we do specifically. We all face challenges, don't we? Phil and I work at Hinkley Point C. We're building a new nuclear power station. Fair to say it's very complex. So the purpose of this talk really is to highlight some of the challenges that we have when involved in demonstrating the application of that for radioactivity monitoring at a new nuclear build. Now, I know what you're all thinking. Award for the pithiest title goes to... Okay, maybe not. But really, the sort of why we think this is an important talk to give is we're potentially on the cusp of a nuclear renaissance in the UK. So it's likely that the next generation of nuclear reactors will face similar challenges to the ones that we faced at Hinkley. Okay, so firstly, some background about the Hinkley Point C project. I know it might seem like the centre of the universe for people like Phil and I, but maybe not the rest of you. So the Hinkley Point C site is on the southwest coast. It's approximately 30 miles southwest of Bristol. It's the first new nuclear power station in a generation, the first since Sizewell B in 1995. And it's fair to say the project's been underway a number of years, and let's just leave it at that. But importantly for this talk, the EA awarded the project 3 environmental permits, including the Radioactive Substances Regulation Permit in 2013. We also received planning permission in 2013. And the ONR granted the project consent for first nuclear concrete in 2017, which began in 2018, and the project's been progressing at pace ever since. So I'm hoping you can see some of the examples that I've got on the screen to try and give an idea of the scale of the project. We've also got some recent images, including the installation of the first civil reactor pressure vessel in over 30 years. So just highlighting some of the quite remarkable progress that's been made to date.
Thanks, Stefan. So, as a sort of environmental professional, I think one of the things that I love kind of talking about, and I appreciate I'm probably preaching to the converted here, but it's just to kind of recognise, and it built into the poster that's going to be downstairs as well, about carbon costs and things like that. So nuclear is low carbon, okay? And to sort of put that into perspective, so the life cycle analysis that we've done at Hinkley based on the as-built designs that we've got shows that the grams of CO2 equivalent per kilowatt hour is 5.5 grams. Okay? It is incredibly low. That's against the ISO certified standard 1440, okay? Fully independently reviewed and everything else. And it includes the fuel cycle, construction, operation, decommissioning, and the disposal of all of the waste as well, okay? It is incredibly low, okay? That's not to say that we don't need those other renewable sources as well, but I have to be honest, it kind of gets my goat a little bit where all we hear about is renewables as being the answer to low carbon. It's not. Nuclear has a really important role to play within that.
Okay, so before we get into the sort of bulk of the presentation, I just want to provide a little bit of context, really. So, best available techniques, or BAT. I'm aware this will be, familiar to a lot of you, but maybe just as a bit of a reminder. There's a legal requirement in the environmental permit and regulations for all exposures of ionised and radiation to the public as a result of radioactive waste disposals must be kept ALARA, considering the social and economic factors. But if you're going to dispose of radioactive waste, you need your RSR permit, and that has within it specific conditions to address that BAT requirement, including on the topic of monitoring. So we've got best, when we say that really at a high level, we mean most effective at providing a high level of protection of the environment. In terms of available, we really mean developed and accessible under economically and sort of technically viable conditions. And when we talk about techniques, we're not just talking about technology, but it's also the design, the operational methods, and the management systems as well. So if something is considered to represent BAT, well, environmental optimization is being achieved, and actually implementing further techniques could lead to being grossly disproportionate. So that's BAT. In terms of radioactivity monitoring at a nuclear power station, there's sort of 3 types from an environmental RP perspective that I want to talk about, really. So that's in-process monitoring. So you've got your real-time or near real-time monitoring of the levels of radiation during operations. For example, the activity levels in your primary coolant. You've got your discharge compliance monitoring. So that's where you'd verify your gaseous and liquid discharges are within your permitted limits. So, for example, you'd monitor your stack or you'd monitor your discharge lines. And then the third is environmental monitoring. So that's the routine monitoring of environmental media to try and understand the impacts of operations on the surrounding areas. So that might be soil sampling, or it might be dose rate monitoring around the site boundary. A nuclear new build, there's just a couple of things I want to say really, but it's to note that there are various phases in a new nuclear build project. So you'll start with design, you've got procurement and manufacturing, construction, commissioning, operations, and then decommissioning. But it's not quite as simple as that. They're not really in discrete phases. They're sort of blurry and they sort of smear across each other. So, you know, for example, it's perfectly feasible that you could be installing some equipment on the ground floor of a building that doesn't have a roof. And actually, some of the associated equipment might still be being manufactured. So that in itself actually brings quite a lot of challenge. So the form of the presentation really is to give some specific examples of challenges we've had demonstrating that. So we're going to look at design, procurement and manufacturing, construction, and then finish off with a pre-operations example.
So as a new build project, we went through a generic design assessment process. We were fortunate in that we had a reference plant, Flamanville 3, our sister plant out in France that we had. I appreciate for those people that are perhaps involved in SMRs, you may not have that, you know, so you know, there's always these kind of different challenges. But we were building the EPR on an evolutionary design based on French OPEX, but then having to align that to UK requirements, but within a local site context. So, for example, things like our reference plant has a 98-metre stack because there's a big cliff behind the site and they need to make sure they've got adequate dispersion. We don't have those situations at Hinkley. So suddenly we're now looking at a shorter stack height because of kind of planning considerations and visual impact. And we then need to look at realigning all of the sampling arrays within that stack to make sure that we've got those kind of appropriate and getting representative samples. And there you're then trying to balance across the varying, conflicting, competing requirements of various codes and standards, making sure that you have sample lines as short as possible, whilst maintaining you're taking a sample from a representative location and having your instruments at a safe and secure location which are easy to access. And those do conflict and those don't always kind of align neatly. You know, making sure that we've got duplicate sampling systems as well. You see here we've got two separate sampling lines. We did have a challenge during GDA about whether we should have a third separate line for regulatory sampling, compliance sampling. But you know, challenges around, well, actually, how do you maintain that? Whose responsibility is to maintain it? Is it ours? But we've just got the two lines. But to think about the sort of stack height, you know, loads of changes that happen during the design process. So looking at kind of computational fluid dynamics to make sure we understand the flows that go through that plenum into the stack. Looking at what that means actually as you go up through the stack, where are we going to be taking samples? What are the right heights? And with all these things, there's never a kind of a lovely sort of inflection point on the graph where it's easy to choose. You're having to make these kind of engineering judgments around that. And when we think about it actually in terms of the entirety of the plant, actually, you know, stack sampling actually is relatively straightforward, relatively well known, understood. We're actually in a position where we had to demonstrate BAT across the entirety of the plant, across all of its in-process monitoring, all of its discharge monitoring at various different locations. And really for that, very much dependent upon the implementation of codes and standards and making sure that through those application of codes and standards, we're demonstrating relevant good practice. Because you've got so many other things that you need to consider. So when it comes to thinking actually about how you move on from a design into a kind of a procurement environment, I have to be honest, when I started on this project, I was probably quite naive in the world of procurement. Thinking about what Stefan was saying in terms of what does BAT actually mean? Well, the A in BAT means available. I assumed that Hinkley Point C, you know, multi-billion-pound project, we were the biggest show in town. People would be lining up, waiting to kind of sell us their wares. How wrong I was. So to give you an indication of technical specification for our plant radiation monitoring system, about 180 detectors across the site. Some of those are nuclear safety classified. The technical specification only runs to 119 pages. However, when you go into that one section which says references, 164 different references referring to code, standards, engineering notes, internal guidance, procedures, those sorts of things. And that's one of 48 appendices of the contract. So when I tell you that when we put this contract out and we had one bidder return a bid, that may not come as a complete surprise to you. So it doesn't matter how good a piece of equipment is, if that tenderer doesn't give me a compliant tender, I can't award, or even if they don't even apply for it, I can't give them the piece of work. It doesn't matter how good the, you know, X, Y, Z sort of piece of equipment is. If I haven't bid for it, they ain't available. So the availability is sort of fundamentally is really quite difficult and is quite a different kind of context. And I think then when we look at that, we've also then recognised that we're working in an international supply chain. Now in the UK, we are very, very familiar with BAT and all of the nuances of that. But trying to get across how do you look at the optimisation of designs and those sorts of things to an international supply chain is much, much harder. I would also say that I think that we were slightly naive as well in our expectation that we'd be able to drive further optimisation into some of these design processes. The harsh reality is that you have a specification which is really difficult to meet. It's likely that people will try their utmost just to meet the specification. They are not going to go above and beyond that. Okay, so I think that actually recognising where you finally get to is really in terms of just trying to deliver that specification. Concentrate on getting that specification right, applying the relevant codes and standards, and then making sure that once you've got that, you really focus actually on making sure that they deliver what you've specified. Fundamentally, builders designed, installers specified. That's what we need to do. Because throughout all of this, we're now in the process of looking at manufacturing non-conformances, exemption requests, deviations, contract variations. So actually, even our original specification that we laid out in sort of tablets of stone, we're having to manage all of those changes as part of this and still to continue to demonstrate the application of that. And I suppose the last point there is then actually as part of that installation is then doing that within a complex environment where actually you've got loads of other challenges as well in terms of where human factors and those sorts of things.
Okay, so construction then, as you'd imagine, an extremely complex phase. So unsurprisingly, you know, there's a vast number of mostly minor, but changes and non-conformances during that during the site construction. So that can range from, you know, non-conforming concrete to defects on a weld on pipework, but you do need to assess the impacts of these changes and non-conformances, but in a proportionate way. That's the key thing, making sure that you've got that proportionality. If you gave full beams analysis to everything, well, you're not going to build anything, are you? So, you know, it means focusing on areas of importance because you have to consider that displacement activity. If you're over there, well, you can't be over there, which is probably where you need to be. So, for example, at Hinkley Point C, we'll have 8 rather large discharge tanks. Circa, you know, 1,000 cubic meters, so pretty big. And their primary functions are to store, you know, provide a containment function for that effluent, but also to sample it prior to discharge to the environment. Now, one of the key environmental design requirements was to, you know, smooth internal surfaces, limit the number of internal components, so you could minimize that particulate and ensure you had representative sampling. However, due to changes to the sort of constructability, the sort of construction method and sequence, there was a change to the design. So I'm hoping you can sort of see there's like a lattice structure of reinforcement beams on the internal base plate. That's been the change for every single one of the discharge tanks. If that wasn't done and the tanks were lifted from outside of the building to the building they needed to be, you'd end up with an extremely saggy bottom. I think we can all agree no one really wants that, do they? So, yeah, I think the key thing to remember for this, though, is that a tank needs to be a tank. So while we've got, you know, this position where we're trying to reconcile against the environmental design requirements, fundamentally, a tank needs to contain the effluent. And also, it's worth considering that the dose to the, you know, representative person from discharges from Hinkley Point C is about 5 microsieverts a year, you know, about the same as a dental X-ray. Okay, and then pre-operations. So I say pre-operations because Hinkley Point C isn't an operational station yet, will be soon, hopefully. But the sort of planning and development of the operational arrangements is underway. And the approach that we sort of typically would take to demonstrating that would be consider regulatory guidance, make use of some of that invaluable operational experience that we've got and the relevant good practice from the operational fleet within the UK, but also in France. We also consider, particularly the very relevant site. So Hinkley Point B shares a local environment, Sizewell B, more similar reactor technology. But there are instances where, UK guidance is entirely appropriate for the existing fleet, but it may not necessarily be aligned to other relevant good practice internationally. So for example, when developing our environmental monitoring programme, we were considering how we would monitor dose rates around the site boundary. And UK guidance recommends the use of TLDs. It's a tried and tested, proven technology. It kind of consists of putting a TLD in a bag and nailing it to a post. Perhaps there are more sophisticated options out there. Well, in fact, actually, we already had one at Hinkley Point C. The plan will be for emergency gamma plume monitoring that we would install these gamma tracer detectors around the site boundary anyway. It enables, live or close to live reading of data. They're much more secure. They've got increased data granularity. So which option is that then? Well, we had to consider a number of factors. Of course, we'd look at UK and regulatory guidance. We'd consider the technical aspects, relevant good practice, availability, ease of implementation, the performance requirements, of course. So we would look at, does it meet relevant international standards on things like energy response, angular response, dose rate range, that sort of thing? How reliable is it? How easy is it to maintain? Well, if you consider the additional burden, we were going to operate and maintain it anyway. So actually, we were able to justify for Hinkley Point C a technology that hadn't been implemented in the UK previously. And one thing I do just want to sneak in, you may be aware of TGN2 and it's going through a revision. Well, TGN2 now encourages innovation and new technologies rather than simply explicitly recommending something. Now, we can't take all the credit and I wouldn't like to, but I'd like to think that we played, our own small role perhaps in the introduction of that sort of text.
Just very conscious of the time, and I've probably got about a minute just to wrap up. So I think, as Stefan said, radiological impact from Hinkley Point C is very, very small. I think another way to look at it is that if we were a coal-fired power station, the doses from our normal discharges of gas emissions will be higher than a nuclear power station. That's how low they are in routine operations. We need to make sure that we're obviously monitoring those things, but we need to make sure that our monitoring is also proportionate. So the requirement for BAT still applies, but it needs to be still implemented in a proportionate way. I'm not saying that our challenges are any harder from retrofitting, they're just different, okay? It's all quite difficult, and I think the earlier presentations around that we saw from Sellafield in the earlier session kind of illustrate some of the unique challenges that they face, and SMRs will have the same challenges as well without a reference plant. We've taken the view of leaning on codes and standards as being a particularly useful way of doing that and pulling on our available OPEX. But you need to be really careful about not cherry picking isolated clauses out of different standards to try and do that. If you're following a standard, you need to make sure you're following it as holistically as possible. And there are those challenges that I say you can't just look at just the design. Ultimately, BAT is about how you implement that, how you maintain that, how you manage those changes. And that's really, really crucial. And, to be honest, the biggest issues that we've got at the moment at Hinkley is making sure that design that we've so carefully pored over actually is realised in all three dimensions as it's built on site. And I think for me, we engage with lots of different organisations. So I was at an industry group yesterday talking to colleagues in Rolls-Royce SMR. We talked to our colleagues in Sizewell C as well. And trying to make sure that we're passing those lessons on as well. So for us, that's a kind of really big thing about making sure we can try and pass all of this learning, big and small, onto into the industry for the future. Thank you very much.
Thank you. Thank you very much. So I'd like, we've now got one of our affiliated organisation presentations. We've got somebody from Unitec, I believe.
Yeah. Thank you. To the beginning. Thank you. Yeah, good morning, everybody. I'm Adam Waring from Unitec Services Group. So we're excited to introduce a new product called ACG Pulse here for the SRP conference in Hull. So you'll all be, no doubt, familiar with some of the other services that Unitec offer. And it's the very last on this list here, which is asset tracking, which we'll be showcasing today. So ACG Pulse have a 30-year history with smart vending and logistics systems. And all of the hardware and software solutions are manufactured and developed in-house in Sweden at ACG's headquarters. So ACG essentially provide on-site RFID technology to manage PPE equipment and garment laundry processes. So the technology can include secure storage, access control, automated dispensing, and also the return of soiled garments and equipment back into the system with automated stock replenishment to complete the cycle. So RFID, or radio frequency identification devices, are small tags that can be attached to any product or garment to enable tracking using the ACG equipment. There's a wide range of products, but essentially you can convert an existing storeroom into a completely controlled area with products like Q-Gate on the top left there. Or you can actually provide standalone solutions for issue and return of equipment or soiled garments with things like Q-Lock and Q-Soil. So all of the ACG products connect to a cloud-based software, which is called QWeb, which enable user allowance controls, access by user, automated stock replenishment, and offer a full analytics and reporting solution. So the essential advantages are simplifying operationally to simplify auditing processes, ensure compliance, and the savings tend to be around inventory reduction, typically around 50% reduction, eliminate loss of your assets and equipment, reduce staffing costs, and all of the solutions benefit from the ACG Pulse lease programs. And that concludes my piece. Thank you very much for your time. Enjoy the rest of the show.
So our next presentation, which is new build, the undiscovered country. We've got John Bradshaw this morning. John is one of the RPAs working at AWE and is currently working as the radiation protection lead on AWE's new build projects, providing input as the RP intelligent customer. John has 30 years experience as a health physicist and RPA at UKEA Harwell and AWE Aldermaston, and is also a member of the RWA body. He occasionally supports AWE's internal regulation function, for example, as part of the peer review of the site safety cases for AWEA and AWEB. Thank you.
Morning. When I was first generating the presentation, one of the problems I had was trying to come up with a catchy title. Oops, hang on. I'll just look. Green bit. Oops, that's not it. Ah, right. The undiscovered country's got two meanings, both of which are both applicable. For all those Trekkies out there, there's a quote from the Klingon Chancellor that basically says, "A toast to the undiscovered country, the future." And this is what's going to be happening to AWE. If you drill back and go back into time and think about what Shakespeare actually wrote, it's the undiscovered country from whose bourne no traveller returns. So basically, having thought about it, it's also sort of applicable to AWE because as it stands at the moment, the current AWE will be changing and will no longer exist. So it's going to, again, be different again. So one of the things that's driving it is that paper, CP 1058, generated in March 24, that basically says the UK will invest in a nuclear deterrent and it's going to be a national endeavour. So it mentions the fact that we were going to invest in the infrastructure for AWE. And basically, when you think about it, AWE is about 75 years old, you know, as you've seen on our stand. Some of the facilities that we've got, we're still working in the first facilities that we had. So our analytical chemistries is still in a building that's about 75 years old. So it's all fallen apart. So we've got to replace everything. Everything must go. We've also got to do our new build program while maintaining site safety and while maintain capability. So we've got to do all those things and deliver the new build. And the timescale is tight. There is a timescale mentioned that I'm not going to mention, but sometimes during the next decade, there'll be a new warhead that's going in a new sub with a new reactor core. So Rolls-Royce, Barrow-in-Furness, and ourselves have got to join forces and get it all out. So it's been a long road getting here. There's lots of learning and experience to feed in from, for example, the old facilities, the current facilities. And the discussion I had with Chris Jones right at the start of this is we won't do what we've always done. We will improve on what we've done before. So basically, we're going to have a blank piece of paper and we're going to try and do something different. So initially, I was given the hub and Mentor. The hub is our labs project. So basically, we're going to consolidate all our analytical capability, some of our engineering function, and build a brand new calibration facility to actually do some radiation protection work. So one of the things we did early on was to argue intelligent customer via CDM, etc., to get RPA support to actually into design through contracting. One of the things we came up with was, if you like, an ALARP radiation assessment process and BAT process that maps up to the REBA stages. To try and sort of like, because one of the things I actually did was review the REBA process and went, it doesn't actually work for us. You know, it just turns around and says, you need a risk assessment. One of the things we built was, right, at this point we need radiation risk assessment, ALARP, concept ALARP, detailed BAT, wherever. We came up with some processes. Now, as time's passed, the number of projects has grown, obviously. That is a picture of the Mentor facility, which will be assembling and disassembling the weapon. That is a nice picture of the hub with, if you like, the engineering wing, the science wing, and right at the top is the calibration facility. This will be the, if you like, our new uranium facility. So this is the architect's artist's impression of what it's going to look like. It's going to be the tallest building on site. And that will be our new plutonium manufacturing capability at some point. Looks like the old one. And it will be operated in a similar sort of way. Now, in terms of the framework, we've got IRRs, REPIR, EPR, the AWE assurance principles. We're also drawing on IEA standards. But what we've actually set out years ago is our design safety principles that basically says, this is what we consider to be good practice for a modern standard building. So we've got a good idea that what we're going to do is nail down in writing. There's also other standards that people are drawing in. So, for example, the IRPCG standards from the Safety Directors Forum, as in the National Nuclear Event Forum. I don't know whether anybody's aware of this, but there is something called the ARC project, the Alpha Resilience Capability Project, where basically BAYS, ourselves, Sellafield, are all collaborating on trying to maintain the skills and the knowledge and the technology to keep alpha awareness and standards going. Because most of the industry, you could argue, is all beta gamma emitters. It's not really, but maintaining that alpha scale, if you want to call it that, is key for the ARC project to go. One of the things that we're finding out as we're going along is people are using, if you like, COTS, commercial off-the-shelf equipment, RGP is sort of like buzzwords to sort of like, oh, it's COTS, it's RPG, and it's like, well, hang on a sec. Drill down and try and understand what you're trying to put across, because at the end of the day, you still have to demonstrate it's a LARP. Not many people can build a furnace that withstands 1,000 degrees centigrade, for example, and you can't go to Argos and get it. So, as everybody's mentioned, there's a distinct age profile across AWE staff, not just ourselves, but across engineers, safety case writers, etc. And one of the things we decided early on as a company is we'll use the intelligent customer approach. And when the engineers have been getting involved with the design engineers, our engineers, there has been some butting of heads at the fence, because they've assumed, or we've assumed we've forgotten how to do stuff, and in reality we haven't. There's also the fact that AWE has a different safety culture and a LARP culture. So when the guys have come down from Sellafield, they've gone, yeah, well, that's just C4 area, and we're going, no, we don't have that system anymore. We've stopped doing it. So there's been some, if you like, education and going on. So one of the things I've got is a new build team, which is a combination of people who are experienced and newbies, as I call them, and I'm also getting trainee placements. So the idea is that when the next generation come along, they'll know what we're doing. They'll have some experience of how we've got to the place that we're going, the journey that we're going on. So it allows us to, support the future. So Anne's doing a presentation about, if you like, on how we're recruiting things. But basically, it's a 2-year program to become a health physicist, and then approximately about 3 years to become an RPA. So there's lots of placements, there's lots of, if you like, ideas that we're trying to maintain to keep the skills capability up to address the wide variety of hazards that we're going. So one of the things I'm trying to do is brief the tech meeting about how the new builds are going, some of the issues, some of the good practices that we're trying to get across. So one of the things I have been doing for a while is meeting with all the contract RPAs, either individually or a monthly meeting, where we have a chat and go, right, what's the latest problem? How's it going? So some of it was, if you like, getting started was, if you like, the documentation. So it wasn't just a case of, supplying the radiation risk assessments. It's all about the company system. So trying to supply everybody with the company documentation to say, right, this is how we're doing stuff. Sometimes we had to write initial RRA, radiation risk assessments, for handover, so that we said, right, okay, this is what we think it is at the moment. As the design RPA, you guys can take it on and run with it. We'll take it there. As it turns out, we're not the only people with newbies across the site. As I said, we've got engineers in site safety case, and even people off site have forgotten that AWE is an old nuclear licensed site. So when people are starting doing the civils projects, of starting to do the dig, we're going, hang on a sec, guys, you need to take soil samples, you need to do some monitoring, because you might find contamination, because it's an old site. So one of the things we've rapidly discovered is we might have to do a bit of, awareness about why we're doing the controls we are. Now, one of the things we've actually been exploring is the relationship between safety case and radiation risk assessment. So ideally, you could make the new safety cases meet the radiation risk assessment via the ACOP by playing around with something called the normal operations dose assessment. There's pros and cons, and it's still something that we need to work on. And if you like, the reverse might not work either, because trying to use a normal dose assessment process that the safety case guys use in a radiation risk assessment might not work. In fact, recently I've had discussions with the safety case guys at AWE going, well, why can't you, the RPAs, generate a non-nuclear risk assessment process for us? And I went, no, that's not our job. We're just giving you the radiation risk assessment for the design. We've not got the skills to actually write you a safety case. We're just RPAs. We don't get paid enough. Oh, sorry, I've just offended the United Kingdom safety case community. So this is going to be a generational thing. A large number of people, at the start of the project are going to disappear off of the project. They're going to get jobs everywhere else, as we discussed in the earlier presentations. So basically it's capturing down the LARP arguments and the LARP journey of how you've got to where you've got to. And it's making sure the design and the operation is going to be holistic. So make sure you can actually maintain the plant and we can decommission the facility at some point. Through life rekit, we've got a plan for a through life rekit at some point. So, like I said, I've been given a blank piece of paper, and we used to use, and we still do use RPE a lot because we've got a whole historic plant where we might find contamination. But one of the aims I'm trying to do is try and reduce the RPE reliance. So one of the things I was thinking about when I was deconstructing or constructing this presentation was one of our inputs into our LARP culture is the concept of zero intakes, which helps us, reduce, our waste arising by applying BAT. So if you're not contaminating people or the building, your waste is going out of scope, essentially. But unnecessary use of RPE can also be a problem. So you need to demonstrate that use of the RPE is a LARP. For example, look at the totality of the problem, heat stress, all these other issues that we know. Now, not many people make glove boxes. So we won't be the only company that wants glove boxes. The Americans want glove boxes. The guys at Sellafield want glove boxes. Everybody wants a glove box. And it's a single point failure. I don't know about you guys, but I still use British Standard 4094 on X-ray and gamma shielding. Now, a lot of the people like the Cerberus guys do MCMP, microshield, etc., etc. So one of the things we've got to have a look at is how we do the oversight, because some of the things that the guys are doing is they're extrapolating on the curves and the models that are in those British standards by using least squares fits. So one of the things we might want to have a look at is, do we need a British standard update? Instrumentation is another little bit of an issue, because as we're designing, instrumentation goes out of date. So one of the things that our colleagues in the instrumentation section and our QPs are looking at is we've got a configured list of instrumentation that we keep looking at and going, right, is this still, what's the life? How's it going to work? Is it going to fall over? They're doing a lot of good work for us to try and keep things happening. So one of the things we're trying to do is, if you like, make sure LARP and BAT are hitting the design. So we've warned the engineers that once you start optimizing your processes, it's not going to look the same as you started off with. Now, we're trying to get it to develop in lockstep with the design. So it all happens simultaneously, and it's a naturally evolving process. But one of the discussions we've had is about BATs is that it's not necessarily still BAT for a new build. So the processes that you've got in your current build might not be the same. One of the fun things about working with AWE scientific community is, as they keep saying, is the science always evolves. And if you like, one of the things we're going to do for various buildings is give people an envelope, design envelope, to allow for scientific changes, because it does actually, it has been a bit irritable when people turn around and say, John, we want to change this little bit of a process. And I'm going, no, hang on. We're trying to build something, let's have something called design freeze where we can actually build the things that we're trying to build. Done a lot of discussions, and I did a presentation to the IMechE on how we vent systems and things like that. One of the things we've been working with the RPAs on is, could we come up with a simple standard for air sampling? So, for example, a gentleman named Stuart Fanning many, many years ago came up with a model using very complicated mathematics to say, what about one sample near a containment less than a metre away? So you could do that. Now, having had discussions with engineers, one of the things they've been looking at and parts is use of computational fluid dynamics. Because what they said is you can use computer programs to model the airflows. But it's prone to, if you like, what the Americans call garbage in, garbage out. So if you put a mistake while you're doing the model, you won't get the right model. So one of the things we're looking for is doing it in a practical way, is saying, right, what we'll do is we'll round up our RPAs, vent engineers, the safety case guys, the qualified person, facility management representatives, and go, right, this is where we want the cams to go. Basically doing it by a practical, we think the airflows are going to be here. Now, we've moved away from paper, which is a good thing in a way. So a lot of the, if you like, the builds are using 3D drawings and model walkthroughs during the layout. And slowly people are actually using virtual reality to actually look at how these buildings will operate. But one of the ideas I had was, well, you know, what about sim facility where you have sim surveyors monitoring sim plant, sim maintainers maintaining the plant? You know, so you could have a computer program like SimCity, but you can trial stuff to see if it is maintainable. Right. Here's some examples of what we're trying to do. Now, some of the things AWE has decided to do is we will try stuff. If it doesn't work, at least we've demonstrated it doesn't work. Now, being a bit of a geek, I was asked to look at neutron shielding for an item, so to speak. And one of the things the guy said is what we could do is 3D print this neutron shielding. Now, theoretically, if the SRP ever actually do a prize for the most boring photograph, hopefully I'll win. So I did some modelling and did some calculations. I went 4 centimetres will give about a factor of 2 dose reduction, which based on the LARP argument I was generating was about all I need. We took the final design through NCMP modelling, which gave good agreement. And one of the things in discussion with various people is, well, if you can do 3D printing for metals and, you know, plastics and things like that, is you could use it to plug holes in, you know, odd-shaped holes in things like, you know, radiography facilities and all these other good things, rather than just put a big piece of wood over the top of it. Now, many, many years ago, I was working on obsolescence with our QP. And one of the things we said was, wouldn't it be great if we could have the CAMs and the criticality detection system linked up to various locations around site so we could actually look at data in real time from the facilities? As time's passing, our new instrumentation will be smarter. So it will know where it is and plug into building management systems. My little colleague Graham Old bumped into me and said, oh, I've had a chat with our QP, Trevor Burkett. What we think we can do is link the CAMs to SIDS to laptops, because since COVID, we've all been given a laptop each. So one of the things we could do is while you're in the office and there's a problem in your facility is look it up and you're already looking at the problem rather than actually going to the facility. Now, many, many years ago, again, some gentlemen asked me to...
John, just to note, 1 minute, please.
1 minute.
Yeah.
One of the things we've been looking at is UV to see if we can detect box holdup. The guys at Bristol are working on something called Overwatch, which is basically a smart neural network that learns how an operator works in the glove box, which we can use for training and demonstration that the guys are going to be safe while they're doing glove box work. So it's going to be a modular system. These are all things that we're actually trying. Right. Thanks for everybody getting involved. For everybody I forgot involved from the list, for example, Daniel West for teaching all the engineers that depleted uranium is actually radioactive. and the guys at Cerberus for doing some shielding calcs for us. Right, thank you very much.
Okay, so now I'd like to introduce Jen Barnes from Momentum, just for our next 2-minute affiliated organisation presentation.
Right, hello everyone. I'm from Momentum. I'm one of the radiation protection advisors. I've been given 2 minutes, and what I thought was I'll just give an overview of what we do and who we are based on a quick ABC. This was harder to do in practice than I expected, so some liberties have been taken on some letters, and I'm going to have to talk really, really quickly to get through this. So in terms of A is for analytical services. We've got laboratories called analytical services. We've got an approved dosimetry service. We were called AMEC and AMEC Foster Wheeler, and we've got the ANSWERS modelling codes. We do BAT and BPM assessments. Based at Birchwood is where I am, and we've got a great breadth of capability. We're very client focused. We're a consultancy. We do concept design, and we do criticality support. We do decommissioning work. We've got dangerous goods safety advisors. We do dose assessment and data quality objectives. We offer EPR advice, engineering design, and environmental protection. We do feasibility studies, fluid dynamics, and fusion support. We do gamma surveys, generic design assessment, GIS mapping, and we have a graduate scheme. We're very health and safety focused. We have some high resolution gamma spectrometers in both our laboratory and that go to site. We do human factors work, and we have a high temperature facility. We do lots of innovation, I hope. We've got a lot of instrumentation. We do IRR 17 advice, and we've got an irradiation facility in Harwell. We used to be called Jacobs, our most previous name, which might be more familiar. K was quite hard. We've got lots of knowledge, expert level, and our team does like a Krispy Kreme donut. We've got low resolution gamma spectrometry systems as well. It's a picture of one that we had on site there. We do leak sealing. Mathematical modelling, these are some of the codes for the ANSWERS suite. We've got manufacturing capability. We've got nuclear site teams. We do new build support. We were previously called NMC. We've got offices in lots of locations. We do project management, we do problem solving, and we offer personal development. We do, I hope, quality work. Was a bit easier. We've got RPAs, RWAs, we do radiometrics, remote operations, robotics, and we've got some recalls. We do safety case work, we do a lot of site work, and we've got SIAL, which is used for waste immobilisation. I'd like to think we've got a lot of talent and we're really good at teamwork. We offer training courses, and I've been there for 21 years. We've got a UCAS accredited laboratory. We do a great variety of work, including visual sample planning. We were previously called Wood Nuclear. We offer waste management, and we can facilitate workshops. We are X-ray experts, hopefully. And could this be where you have your next role? And I hope I've not sent you to sleep. Thank you very much.
Right, our last presentation for this morning is Optimising Organisational Learning to Reduce Radiation Risk at Hinkley Point C. And we've got Sean Lodge and Paul Broxham to deliver this presentation. So Sean works at Devonport, held roles as a health physicist in operational and radioactive waste functions, gaining his CRADP and RWA certification. Sean is currently working on the development of operational arrangements in both radiological protection and radioactive waste management at Hinkley Point. And Paul started his career in contaminated land, focusing on non-nuclear sites. Paul joined Hinkley C in 2022, initially as an environmental engineer, and is now environmental lead for the commissioning programme.
Right, good morning everyone. Today we would like to talk to you about how we're using the power of organisational learning to reduce radiation risks at the UK's newest nuclear power station, Hinkley Point C. So in this presentation, when we discuss radiation risk, we're talking about risk to workers, the public, and the environment when the power station is operational. Now, This hazard isn't present yet, so in order to prepare for the future, we need to learn lessons from elsewhere. My name's Paul, and I'm the environment lead for the commissioning programme at Hinkley. I'll now be talking about how we reduce radiation risk to the environment. I'll be joined by Sean, who's a RP engineer from our pre-operations team, who will be discussing occupational RP. Now, before we discuss organisational learning, we'll give you a brief overview of the project itself. As you're probably aware, it's the first new nuclear power station to be built in the UK for around 30 years. Will generate a huge amount of low carbon energy once the site is operational. For a bit of scale, the picture here is the world's largest electricity generator being lifted into place. Please note the worker in the green circle for scale. Now, at any one time, we can have up to 15,000 people on site, plus thousands more in supporting roles and in our supply chain. This presents us with thousands of opportunities to learn. And just to underline why we think organisational learning is important, I'll paraphrase this quote from the Nuclear Institute. They found that for most events, OPEX was actually available, and if it had been used, it may have prevented the event from happening in the first place. I'm going to hand over to Sean now, and he's going to tell you a bit about how we plan on ensuring that we're capturing this prior knowledge.
Cool, thanks Paul. So, hi everyone. I'm just going to give you a bit of an overview of what organisational learning is and how we're doing that at Hinkley Point C. So, one of the biggest challenges that we face is this is a future operational hazard. We currently don't know how to deal with those hazards, but we can look at our design specifications, we can look at regulatory requirements, but we can also look at what have our sister stations in the fleet done while they've been operating, what have the other EPRs across the board been doing. The challenges we face are very unique. We're trying to build the first in a generation of a nuclear reactor, and we can't do that without looking at what has industry done already. However, this isn't just take. We're very aware that this is given as well. Sizewell C has got spades in the ground at the moment. There's SMRs that are looking to come online in the near future. We also want to make sure that we can set a good foundation to pay it forwards, tying into the theme of regeneration and sustainability. So, what actually is organisational learning? It's not a lot more than knowledge management. And knowledge management is split into three main parts. Firstly is capturing information. That can be done in a variety of ways, and they all feed into this big mess thing called organisational learning that's quite hard to define, actually. Just as an example of a few of them, we've got operational experience. So for us, we've got lots of industrial radiography happening on site. So we're in a position where we can look at what's happening there and how can we learn to improve when we come into operations. But we've also got the experiences of others. As I've just said, we can look at Fleming. What issues have they had and what can we do to improve and learn from them? And I can't quite read that from here, but I think that's international reporting. So we're also looking at WANO, SOERs and other references to be able to learn. The next part of it is taking action. There's no point in taking on that knowledge if you take no action on it. So what we've got at Hinkley Point C at the moment is a company reporting tool called Insight. There are various things that we can report. That could be from learning something new at a conference like this. It could also be observing a non-conformance where we want to take action to improve in the future. And then the next thing is transferring that knowledge. So we've seen something, we've made a record of it, but that's completely useless if we don't tell the people about it that need to know about it. One of the ways that we're currently doing that at Hinkley Point C is flash alerts. So in this example, I don't know how well you can see that on the board, but we've got a lot of work on site where there's fumes and dust and exposures and those kind of situations. And there are obvious analogies for us to learn from when it comes to radiological protection controls. So hopefully I've set the foundation there of what organisational learning is. And if you could just try and bear in mind those three topics, we're going to be putting little coloured chevrons throughout to try and tell you some stories of how we've used that in real life. So I'm going to hand back to Paul.
Thank you, Sean. Now we're going to talk a bit about how we're putting this organisational learning into practice to reduce our radiation risk. I'm going to start off by talking about one way that we're controlling our environmental dose and how organisational learning is helping us to do this. When it's operational, Hinkley Point C will use lots of specialist equipment to process, discharge and manage radioactive wastes. This equipment was designed to apply the latest, best available techniques for managing rad waste. The design's very clever and has the capability to reduce environmental dose to ALARA levels. However, we'll only be able to do this if we have the right plant controls in place to operate these systems to their full potential. To provide these controls, we're developing environmental specifications known as E-specs for key areas of the plant to in effect bridge this gap between design and day-to-day operation. So what are E-specs? Well, they're instructions for the operators of HPC, directing them to operate the plant in a manner that minimises our impact on the environment. They define actions that we must follow, such as appropriate return to service times when key equipment breaks, and maximum allowable activity concentrations in our discharges. Each E-spec is formed of a specification used by operational staff, which provides the requirements, and a justification document which is used by subject matter experts and provides the technical underpinnings of each requirement, promoting the application of BAT. The overall goal is to protect the environment and generate energy sustainably. So, what are the key requirements? E-specs need to be technically sound. We need to minimise dose and comply with our permits. And we also need to protect our often expensive equipment from unnecessary damage, which is of vital importance given that we have a design life of a minimum 60 years with no planned replacement for some of our key environmental protective equipment. E-specs will also need to be usable and understandable. These documents will be used by people who might not be specialists, but who will be on the front line making decisions that can impact our environmental dose. And these are two very different challenges, but we are using organisational learning to address both of them. To give you a bit of an idea of the journey we're on, this is a process we've followed so far. So for the E-specs, we've allowed 2 full organisational learning cycles so far, beginning with gathering information from a range of sources and then developing our process. In 2023, we produced revision 1 of all of our E-specs. Then early last year, we used review feedback to develop a list of open points to inform future improvements. We then closed out our first learning cycle and started the next one by working through some of these open points. We used technical workshops, a bit of data gathering, including OPEX, and optimised the process structure and templates, which were issued at the end of last year. We've still got quite a few open points that need to be answered, and we're aiming to do this as we produce revision 2 of the documents, which will close out our second cycle of organisational learning in the process. We'll carry on repeating this all the way up to the big switch on and beyond. And so now we've looked at the process as a whole, just a quick look at some of the specifics. So we baked organisational learning into the E-specs from the start by harvesting knowledge from subject matter experts within the industry to ensure the first objective of technically sound documents. Once these documents have been produced, some of the very same experts then provided review feedback to ensure that the knowledge that we'd obtained had been captured. Now, why is this so important? Well, although we're a novel reactor design for the UK, the processes involved often have clear equivalents elsewhere, meaning there is learning available for us to utilise. We're going to learn a lot of lessons ourselves, and it's essential that we pass that learning on to others, primarily to our colleagues at Sizewell C, but we hope that this will extend to other new nuclear projects in the UK as we regenerate our civil nuclear industry. And I just want to have a bit of a note on our second objective regarding usability. We've held a lot of workshops on this topic, incorporating a wide range of stakeholders and diverse perspectives to achieve a best fit for the E-specs. And we also attend workshops aimed at promoting standardisation that are run by other teams. And that's a really, really useful source of information for our process. I just wanted to also give a bit of recognition to the importance of diverse perspectives. A key question that we get asked is, well, how do we verify that all of this learning has made its way back into our documents? Well, we do this through review by people with a diverse range of technical backgrounds and experiences. It's a really strong test of usability and understandability. This slide just lists some of the different roles held by people who've reviewed the HPCE specs so far. Every single one of those people has brought unique skills and perspectives to our process. I'm now going to hand back to Sean, who's going to talk a bit more about occupational rad protection.
Cool, thank you. Yeah, so we had a bit about environment there. I'm going to move on to occupational rad protection. So we've got future operational hazards. Like I said before, we've got industrial radiography happening on site, but the context is completely different in the future. So what are those? Well, I mean, we've got our design drawings, like I said, but we don't fully know what they are. So we've got to rely on that organisational learning to help us get there. And part of what we need to do is obviously keeping our people safe. We're trying to restrict their exposure to radiation. In order to do that, we've written a series of radiological safety rules. The purpose of those is to interpret IRR 17 into a way that's in the context of Hinkley Point C for us to be able to implement our legal requirements. And to implement those, there's two areas. There's the operational arrangements. So that's all of our documentation that we're producing that tells us how to write risk assessments, for example. And it's all of our equipment as well. So our instrumentation. So that's our plant and process. But in terms of our people, we're trying to develop early on a strong radiation safety culture. And if we've got a strong radiation safety culture, we'll have nice, happy workers like our young apprentice Danny here. So when I first took on the task of trying to develop and implement a strong radiation safety culture early on, I actually found it a really abstract conceptual topic that was really difficult to define. It's not tangible. It's not something that's easy to measure. In order to get over that first step of trying to figure out what it is, I undertook a literature review. And from there, there's two things that I just wanted to share with you. Firstly, I couldn't find a succinct definition of what radiation safety culture is, so I made one up. The text in blue there for audience participation, can anyone recognize that and tell me where that's from? Sorry? Yes, that's from the WANO definition of nuclear safety culture. So I've just changed a few words around to turn it into radiation safety culture. And then secondly, which I found this quite interesting, radiation safety culture resonates better with the workforce that are at the coalface than radiological protection safety culture. The reason I wanted to highlight that is just to give a highlight to the power of language and the importance of communication. If we don't communicate to people properly, we're not going to be able to get buy-in to what we're trying to achieve. So the next thing that I did was I looked at, well, what are the things that we need to develop within this safety culture? Broadly speaking, there are two areas that we want to focus on. There are knowledge elements and there are behavioral elements. We need to do things to be able to support our employees to get there. But what are those things we want them to know? Just for a couple of examples, we want people to have a fundamental knowledge and understanding of what alert means. That will enable them to display the correct behaviours to manage their own and their colleagues' dose exposures, but also behavioural elements. We want to foster people to have a questioning attitude. We want to be able to learn from what they see. The next steps that I took, so I undertook some benchmarking against the operational stations, and I just wanted to share with you a few things there that I learned and included in a report that I wrote on this. Within the RP team, we need to focus on our own culture. One of the things we need to do is have visible leadership. We can't be seen as sitting in ivory tower saying, "Thou shalt not." We need to be on the shop floor, setting the example and influencing others' behaviours. The second one is administrative controls. Something that I've observed while I've been in the industry is I often feel like administrative controls are just there purely for compliance, and the safety benefit is not often demonstrable to the people that you're expecting to follow those procedures. To get people to follow procedures properly, we really need to have that procedure demonstrating why it's important. The next one is training. Obviously, we'll be involved in the development of training as the subject matter experts, but it's also the involvement in the delivery of that training. We want to be able to network with people early on, demonstrate that we're approachable, and form those relationships. Then the next thing is the transient workforce. I know it's not too relevant, but during the current phase, we've got lots of people from lots of different backgrounds. And as we move into the operational phase, we're going to have outages where we've got people that have worked in all sorts of different countries and all sorts of different environments. We need to make sure that we tailor and target training towards the individual people and their individual needs. So there's a bit of forward planning as well. We're not going to solve this in a day. So the forward planning was around 3 main pillars. Who are our target audience? Who are we going to want to train? Who do we need to have a strong radiation safety culture? How are we going to deliver that? That's through the things like training that I just discussed, but also setting those examples. But the thing that I've found most difficult is how we're going to measure that. We're going to achieve that by recording events inside the system that I mentioned earlier, and we can do trends of things like personal contamination events. If we see a sustained trend in something, that might be a little red flag to us to investigate what's the culture like at the moment. Is there anything we can do to improve behaviours? And for the delivery of this, I authored a company document. The purpose of that was to be able to share what I learned to people that would be interested as we approach operations. I started a program of apprentice OPEX sessions. This is just my personal view on this. I find that we often talk about the high level, understandably, we talk about the high level OPEX, the operational experience for things like Chernobyl or 3 Mile Island. It's really important to understand that nuclear safety culture. But I feel like we seldom discuss things like what do you do when you lose a source, or what do you do when you've got a personal contamination event. So they've been going really well. And Danny from earlier gave that a big old thumbs up. He was happy with that. And we've developed a radiation safety culture program that we're going to try and implement over the next few years that you can see along the bottom. But it's important for us not to rest on our laurels and just develop those things and move on. We need to have a review cycle. We need to make sure we come back to it, have a peer review, and make sure that we're still where we need to be. So the benefits of a positive radiation safety culture. So a lot of the academic research and stuff through the SRP that I found, the 3 things there feeding from it are really important to the theme of this conference about sustainability and regeneration. There'll be a reduction in longer term costs. That comes from things like reduced events means reduced regulatory interaction. There'll be an increase in productivity and performance. That comes from people feeling involved in a process and like their voices are heard. They're bought into what we're trying to achieve. And then encouraging that organisational learning will help that review cycle continue. That will help us feed into our net zero mission as one of many different cogs. However, I was cognizant that this hasn't been done alone. There's a wider safety culture. For example, environment safety culture, quality safety culture, and the bigger nuclear safety culture. We're not working in silo on this. We're trying to work together so that we're not reinventing the wheel. I'm going to hand back to Paul to conclude.
Thank you, Sean. So in conclusion, we've taken you on a brief tour of how we're using organisational learning at Hinkley Point C. We can view it as a funnel, as shown here. So we're taking org learning in from a variety of sources at the top. In the middle, we're then baking it into our operational arrangements, improving our plan to protect workers, the public, and the environment. And then hopefully we'll reap the rewards in the future through sustainable electricity generation, optimised doses to the environment, the public and workers, and also through future propagation of organisational learning, primarily to our colleagues at Sizewell C, but also to other new build projects and the wider industry. Thank you very much for your time.
Cool, thank you.
Thank you for all of our speakers. So we had a lot of questions coming in, which is always great. So there's already 12 questions in. Luckily, no one wanted lunch today, so that's all good, because apparently we're going to try and solve a debate of how do we really tackle a LARP and BAT in the next 20 minutes. So there's lots of good questions. I'll kick it off. We probably won't get through them all, but what I want to make sure is all the speakers get a copy of the question so we can get them all answered outside of the meeting as well. So as a starting question, this is a joint one to Phil and Stefan, but also to John Bradshaw. It seems Hinkley Point C and AWE are taking different approaches to incorporating ALARP, ALARA and BAT into new build. HPC makes reference to ALARA and relying on specifications. AWE had a bit more of a focus on ALARA in the contacted design process. Are we talking about different approaches, and are there issues or risks with either one? So maybe we start with Hinkley and then go on to AWE.
Yep. Thanks, Pete. I think fundamentally, no, there isn't a difference between it. I think the thing is you're looking at the fact that there's a framework in place about how we look to demonstrate BAT and ALARP, and that you're looking at different situations. So from a Hinkley Point C perspective, as I mentioned, evolutionary plant. So we have a reference plant out in France. That in itself is based on the 4 previous reactor designs, remembering that, UK, 7 AGRs, 7 designs, France, 58 reactors, 4 designs. I think we could probably all think where the right ratio is on that. Okay, so we've already got an evolutionary design that we're building on. And so therefore, from our point of view, an awful lot of the work that we're doing is about how do we make sure that gets implemented into the UK in that context. Where we have had to design new buildings, new facilities, new pieces of equipment, then actually the similarities are kind of much more closely aligned to AWE's position, where they're doing bespoke facilities for the first time.
Yep.
So I think you've probably just seen sort of two sides of the same coin through a particular kind of lens there, which perhaps amplifies those differences, but then I don't think they're necessarily there in reality.
No, as Phil said, we've got the framework in place, and we're going through it as the design develops, joint approach with BAT and ALARP.
Fantastic. Okay, next question, just to make sure everyone gets a chance to get a bit of a grilling. For Sean and for Paul, trending events and dose are passive measurement metrics. Did you identify any leading positive measurement metrics through this work?
I'm not sure how to answer that on the hoof, to be honest. I'm struggling to think back to the project. I'm quite happy to come back to that one by email.
One positive example I've had was just for engaging with colleagues at other power stations and also our colleagues in EDF's nuclear operations business, just around good and safe operation of rad waste treatment systems. Things that are very sensitive to changes in pressure, temperature, moisture, and things where you can really do damage to a system inadvertently if you don't follow those requirements. So getting that knowledge from people that have operated similar bits of kit before has been invaluable to us when we're setting things like the operating envelope for bits of expensive kit.
Thank you. And of course, we'll give an opportunity for everyone to respond via email as well. So another reoccurring theme that happened in a number of presentations was the mention of relevant good practice. I told you we're going to try and solve all the world's problems in a short period of time. And in particular, we heard from yourself, Phil, and Stefan about how you only had one particular bidder for some pieces of equipment, and you talked about the huge quantities of standards. John, you mentioned about RGP as well. So does the huge quantity of standards, does RGP in itself potentially actually become a challenge in its own right, and potentially actually a vulnerability to allow us to build, construct, and diversify? Easy question.
Thanks, Pete. Can I just take world hunger instead? I guess the point there is it is really complicated. I don't think there is an easy. If there was an easy solution, we'd all have come up with it ages ago. I think the bit for me, I suppose, is that focus on what is it you're actually trying to achieve, and focusing on those key areas. I think that one of the challenges for me is about how do you focus on what's actually important, what actually makes a difference, rather than getting distracted. And we've already referred to things like kind of displacement activity. So out of those, all of those codes, and so I'm not saying that we were an exemplar in terms of those 164 references. I think that probably illustrates why we didn't get the returns that perhaps we could have. Could we have relaxed some things? Sometimes adding complexity doesn't actually add improved performance or safety.
No. Yeah. We've been there.
That could be a new quote for a new conference. Anything you want to add further on that, John, or are you happy with that?
No, it's one of the things we've discovered is if you look at different practices across the industry, and if you like doing, as these guys have done, is the organisational learning, is what is relevant to your safety culture and how the way you want to operate your plant. You know, so there is a bit of, you know, what AWE do might not work at Sellafield, for example. You know, so it's embracing the wide diversity of, if you like, all the different issues. Everybody's got a different safety culture that works for them, and that in turn says, right, is that RGP that you're trying to input, I've used it as a buzzword again, is what you're trying to do relevant, good practice to your concepts of how you want things to work?
And I think just building on John's point, I guess that's the really important point. You know, the whole point of relevant good practice, you have to be able to demonstrate that it is relevant.
Yeah.
And I think, you know, that I think we can all appreciate that, you know, the world is much more nuanced and much more subtle, that very rarely we're in decisions where we go, A is definitely a LARP or BAT, B is definitely not BAT or a LARP. Quite often they come down to nuanced decisions based on engineering judgment around which site. Both could equally be demonstrated as being BAT and a LARP, but depending on what the culture is, what the organisational state is, what the operational kind of configuration is, that you might have a leaning slightly more one way rather than the other. But you're often talking about fag paper type decisions rather than, you know, kind of polar extremes.
Okay. The questions keep coming in and I keep on going, these are interesting ones. So actually, this is one actually could apply to all the speakers as well. You know, we've mentioned even within the definitions of radiation safety culture, a LARP, we've talked about BAT, and we've talked about these variety of different factors. Okay, so you know, Phil, you started off your talk speaking about carbon emissions. John, you've mentioned various other factors as well that go into your decision process. We've talked about the balancing of communication as well. So do any of the organisations have an approach to holistically treat BAT and a LARP, whether that's just two concepts combining, but also those wider factors? And how have you gone about it? Trying to amalgamate multiple questions together. So as I said, we could have a conference all on this.
Well, okay, I'll have a first stab. So for me, one of the things that, you know, having been on the Hinkley project for a long time and having sort of developed the environmental safety culture, developed our approach to BAT, the thing that we sort of focused on was what we use the term environmental optimization rather than BAT. And actually, even now, I'd probably now just reflect it back to being into an optimized position. And for that, I think very much, I was very conscious, I didn't want to be in a position where we get to a situation where we say, the BAT decision is A, the ALARP decision is B, and some poor sack in the middle and has to decide what the right answer is. If you get to a position where you've got a discrepancy there, then your BAT assessment hasn't considered all of those other factors, and your ALARP decision hasn't considered all of those environmental factors. So really, we should be looking towards a much more integrated approach. And as part of that, we also then need to make sure we focus on not getting completely carried away with the radiological side of stuff. And I appreciate that might be heresy within an SRP conference. But, you know, there are other factors out there, be it sustainability, be it conventional health and safety, all the other things. Ultimately, we need to make sure we're getting the right balance, having considered all of those factors in the round, rather than having separate decisions for separate isolated situations. We need to bring it all together. That's the focus.
We did actually have a look at this some time ago, and we said, right, what we could do is, as Phil said, is do ALARP arguments, BAT arguments, and say, right, and try it in a process and go, right, okay, the decision maker's got to pick one. As Phil said, it doesn't really work because you've got to look at the holistic argument. The classic one is decommissioning the glove box base plates in our old facility. Is a LARP and BAT argument says stop at low level waste. The biggest hazard is the fact that 3 metric ton. So if there's a lot of weight there that if you drop, it's not going to go down well, even if you're wearing steel toe caps. So it's the entire holistic argument across the piece is to go, right, okay, what does it look like? Taking into all the arguments.
And have we found a culture piece about that holistic culture, that holistic safety culture? Would you have a view there?
Sorry, is that? Yeah, there we go. Yeah, so I think Phil summarised that high level stuff really well. I've got a history in radioactive waste management and operational health physics, and there are so many analogies between the two. I think it would be almost naive of us not to try and figure out how we make those things talk to each other as we develop those arrangements. And it's not only at our kind of professional level of writing these documents and helping steer the business towards decision making. There's then the question of how do we drip feed that down to enable people to make the right decisions on the coalface. Yeah, so kind of question. I've just got more questions now.
And so have the audience. I think this is a really important point. We've kind of demonstrated already here that ALARP and BAT and ALARP is not simple. So even how do we communicate that to a day-to-day work is really difficult as well. So I'll end on one question, and apologies for not getting to a lot of these, but we'll try our best to answer them all afterwards. This is a nice, easy one for everyone, and I promise this one is easier. What's your most significant challenge you have faced within new build? And so maybe we start from this side and move that way. So Stefan and Phil, do you want to start first and then go on to John and...
Change management and configuration control would be mine. So I think recognising that, when we applied for the permit application back in 2011, it was granted in 2013, so 20 months later. That was based on a reference design, a basic design. Where we are now, we are getting the isometric drawings and the execution design through for the final sampling pipework. That's 12 years later. Not everything is quite as we originally intended 12 years ago, unsurprisingly. So actually that change management, and crucially within that, there are thousands of changes that have happened on our plant over that time. Which ones actually are really important to us? Which ones do we actually need to scrutinise and actually pay particular attention to, and not get distracted by some of the shiny stuff that other people might be, which are very important for other reasons, but perhaps from our point of view, we don't need to get encumbered with.
Okay. John, you want to throw a different one in?
Sort of agree with Phil about, if you like, the configuration management, because as I said in the presentation, science changes all the time, and it's providing the new buildings with an envelope that basically says, okay, you can flex this much, but if you want to do something a bit further, you're going to have to go and talk to the exec about how you're going to do design. A lot of it, the other thing I was thinking of was the ALARP journey. As time passes, I'm going to be handing this over to my colleagues to actually pick it up. And it's making sure that we've captured everything about how we've got to where we've got to.
So this is a personal one for me rather than anything to do with the business directly. So I moved from a hectic operational site at Devonport to pre-operational site at Hinkley Point C. So it was the biggest challenge, wasn't it? That was the question. So the biggest challenge for me was the change in my work practices. I was very used to constant bombardments of questions and things break in and what do we need to do? And it felt like there was constant things that I was delivering and achieving. And we've got lots of big tasks to do. And the ones that I'm kind of leading with, it took me quite a while to not think about the end goal, but break that down into manageable chunks and then start ticking those off as the things that made me feel like I was delivering.
Do you want to add anything in, Paul?
I was going to say, I agree with what you said, Phil. I think managing change is one of our biggest challenges at the moment. And I think at the moment we're starting to move into the commissioning phase of the project. And I think it's understanding how all the different, very complex activities that are going on interact with each other. We're currently a massive construction site, but we're about to start commissioning like nuclear significant equipment. And it's understanding how those things are going to interact and how we're still going to keep doing things safely. So I think that's a big challenge for the project as a whole.
And Stefan, I feel we've left you out. Come on, you've got your answer.
Yeah, and I've had time to think
Nearly.
as well. Yeah, it's quite an easy one for me actually thinking about it. The one that's probably I've had to get counsel from Phil about is, and he referenced it in the slides actually, that fact that we've got an international supply chain. So we didn't go into all of the detail, of course, and we don't just require that they meet the specification. We do require them then to submit documents that says that if there has been any change to design, that it's optimized, they've considered that. And that can be quite a challenge to get that document approved. So often we'll arrange, calls with the supplier, and it's sort of, what is BAT? How do I demonstrate that? And you're trying to explain this concept. We've got contracts with suppliers from China and France, and I'm sure there's people at this conference aren't necessarily particularly au fait with BAT. Well, how do you manage that difficulty with sort of international suppliers? That's been quite tricky over the years, I'll be honest.
Thank you.
I mean, one of the other things I was just thinking of out loud was the challenge, because, like I said, I've been given a blank piece of paper to say we're not going to do the way we've always done things. But there is the argument that, but we've always done it this way, John. This is how it works. And it's trying to take people on that journey again.
And it's a really interesting point that people mentioned this the ivory tower was mentioned, I think it was in the last talk. And this is another thing when you look at it from an international supply chain perspective. The people all around this table are partly the ivory tower, specifying these wonderful requirements. And, we should remember that only the requirements that come out of the ALARP and BAT post is only a small subset of those total requirements. If you ever want to look about requirements management challenge, I recommend reading the 55,000 page DCO application for Sizewell C, supported by 38,000 pages of supporting documents, and how you're going to manage all of those commitments as well. So it's a challenging thing. We're not alone in being one part that contributes. Thank you to all of speakers. They've been all brilliant. The fact you've triggered so many questions, which are still coming in, is brilliant. So I hope you all put some time aside to answer those at some time. So can we just have a quick round of applause for the speakers, please?